Welcome to Chapter 5, Lesson 1. This lesson is particularly going to be about lines and the angles that we make when we have different types of lines intersecting or when they're parallel to each other. The vocabulary is going to be on the next page because you're going to see that we filled in a worksheet so that we could better organize the material as we were presenting it to you. So here's our vocabulary. Our first one is perpendicular lines when two lines intersect and create right angles. So we see that box over here is representative of what a right angle looks like. And we use this symbol that looks like an upside down T as the symbol to represent perpendicular. And we're going to be using that as we move forward. Next, we have parallel lines, and that is when two lines do not touch. And their symbol is just two small parallel lines. Pretty hard to forget, but notice these are two perpendicular lines. These are two parallel lines, and they are symbols that represent those exact definitions. Moving on, we're going to add something new, and that is what's called a transversal. This line here is a transversal, and it is a line that intersects two or more lines and creates 8 angles. And if we see here, the blue is our transversal, and then those angles are where I'm putting these red dots. And those angles actually create certain angle pair relationships that we're going to use in this chapter. Next, we have interior angles. If you see in the picture to the left, it has 3, 4, 5, and 6 labeled. They are angles that lie inside the lines. So interior means inside. Then we have exterior angles, which in the picture on the left are labeled as 1, 2, 8, and 7. And those are angles that are outside the line. Exterior means outside. And now we're going to move into those special new relationships that we're going to see. We have what's called alternate interior angles. And those are interior angles that lie on opposite sides of the transversal. And you can see in the picture to the left, they have them labeled, such as C1 and C2 that I'm marking in red. Notice they are on opposite sides of the blue transversal. And if you notice, just with a small observation, those angles look like they should be about the same size. And we're actually going to use that as we move forward because they should be what we call congruent to each other. It means they should be the same. And in purple, I'll mark it that D1 and D2 are also alternate interior angles. Next, we have alternate exterior angles. Those are exterior angles that lie on opposite sides of the transversal. So again, we have our transversal, the line that crosses two other lines. Exterior means the angles on the outside, and alternate means different. So when we say alternate exterior angles, we're talking about angles on different sides of the transversal, but on the exterior. And again, using some informal observation, we should see that what I marked in blue look kind of the same. And the angles marked in purple also appear to be similar to each other. Those again are going to be what we call congruent angles. Next, we have corresponding angles. Those are angles that are in the same position on the two lines in relation to the transversal. And when the lines are parallel to each other, that is when they have the same measure. So in the case of the picture on the left, we have this angle J1 and J2. And in an earlier definition, we know that L and M are parallel to each other. And so when we look at those two angles, if you think about taking those parallel lines and squeezing them together, then J1 and J2 should actually be directly on top of each other if we just slide those angles together. Again, we would describe those as congruent angles. We're going to look at a couple more definitions that are kind of a review, but I want to make sure I cover it for those of you that might not have seen these before. Vertical angles are opposite angles formed by the intersection of two lines. The angle measures are congruent. So in this case, if I look at angle 1 and angle 3, those are congruent to each other. Then we have complementary angles, which are two angles that when we put them together, their measurements add up to 90 degrees. And then we have supplementary angles, which are two angles that add up to 180 degrees. So as we move forward, we will have some examples. And in those examples, you're going to be asked to identify what relationship two angles have, and also be able to identify, if I give you the measurement of one angle, you can find one of the other angles in the picture. So here we are moving forward. Now this picture on the left, you would need to copy down into your notebook. Now let's take a look. I want to first start with angle 1 and angle 7. And I'm going to mark those with these dots real quick so we know where we're at. Now angle 1 and angle 7, we want to classify them based on our definitions. One of the first things I like to look at are these interior angles, exterior angles, or both? In this case, these are exterior angles. So I'm going to go ahead and write that down. So exterior angles. And then we want to ask ourselves, are they on different sides or alternate sides of the transversal? As we see, if I highlight it real quick in blue, 1 and 7 are on alternate sides of the transversal. So we will call these alternate exterior angles. So we look at it piece by piece and try to pull together the information we have. And it's helpful to look at it in terms of where it's located and where the second angle is. Notice how I looked at exterior or interior first, because that's usually going to narrow down to only one or two of the other angle pair relationships. Next, we're going to look at 2 and 6, and I'm going to put a purple mark near where they're at. And then we're going to ask ourselves, are these angles in the exterior, the interior, or both? In this example, 2 and 6, we have 2 as an exterior angle and 6 as an interior angle. And notice that they are on the same side of the transversal. These two angles are in the same position on their respective lines, so we call these corresponding angles. Now, finally, we're going to look at 4 and 6. So 4 and 6. I just put a green dot near them. Are these angles interior, exterior, or both? In this case, they are both interior angles. And then we want to ask, are they on alternate sides of the transversal? They are on opposite sides of the transversal, so we would call these alternate interior angles. So that gives us a process that we could follow to better understand how to classify these angle pair relationships. You can start by looking at what side of the transversal they're on, or you could start by figuring out whether they are interior or exterior angles. That helps us narrow down till we get to our definition. Now we're going to look at two examples where I give you an angle measurement, and we use that to figure out what the angle we asked for is. So we want to find angle 3. Now, many questions like this would ask you why. So as part of this, I'm also going to list what their angle pair relationship is. So let's start with the first one. It says find angle 3 if angle 1 is 40 degrees. So I'm talking about this angle and this angle. Looking back at our definitions, we have angle 1 is on the exterior, angle 3 is on the interior, and they have a transversal in common. This line here would be a transversal. So that means these are corresponding angles. Well, by definition, corresponding angles are equal to each other. So the measure of angle 3, showing you some new symbols, should be equal to 40 degrees. Because angle 1 and angle 3 should be the same. Now let's look at angle 10 and how it relates to angle 1. So find angle 10 if angle 1 is 52 degrees. So here's angle 10 and here's angle 1. Now, these angles are from previous notes, so from a previous class where you guys would have learned about angles adding up to a certain measure. Angle 1 and angle 10 are examples of supplementary angles. And because of that, the measure of angle 10 plus the measure of angle 1 should equal 180. Like we're solving an equation, let's substitute in information that I have. Well, I know that in my example, we'd have the measure of angle 1 is 52 degrees, and that should be equal to 180 degrees. In order to figure out what angle 10 is, I now need to subtract 52 degrees on both sides of my equation. And I can figure out that the measure of angle 10 is equal to 120. Let me double check here. 8 degrees. So for this lesson, these are the type of problems you're going to see. And it pulls from our algebra skills that we've been working with up to this point. We have an example here where we had to solve an equation to figure out what the missing piece was. Now it's going to be your guys' time to practice.